Aircraft carriers are versatile and dynamic, and because of their size and weight, they can undertake a high number of missions to carry the payloads required to achieve multiple desired results in support of strategic military activities. The Ford-class aircraft carrier would be the most sophisticated ship on the sea, ensuring that the Navy maintains a prepared and robust power for the foreseeable. It is built on the heritage of today's Nimitz-class aircraft carriers as well as the investments the US Navy has made since World War II. But then the question arises as to why an aircraft carrier is important. An aircraft carrier is perhaps the most important sea-based resource, and its capacity to transmit tactical air power over long separations, including air interdiction, anti-surface warfare, offensive plus defensive counter-air, AEA, as well as AEW makes it unrivaled military equipment. Supercarrier USS Gerald R. Ford. But then you might think, why is the USS Gerald R. Ford so popular among other aircraft ships that the US Navy possesses? The main reason for that is because it is an incomparable advanced technology-induced, high-speed and optimum performance aircraft ship. More reasons why we have used such high-praising words for it can be found further in the article. The USS Gerald R. Ford is a prospective $13 billion ship featuring a massive flight deck and a revolutionary electromagnetic technology for aircraft deployment. It is the premier ship in her generation of aircraft carriers for the US Navy. The ship is dedicated after Gerald Ford, the 38th President of the United States, who served in the Navy during World War II and saw battle on board the light aircraft ship Monterey in the Pacific Theater. In a major military operation, the Gerald R. Ford class is expected to be the advanced prime resource for emergency preparedness and immediate decisive strike force. Forward presence, deterrence, sea control, force projection, maritime security, including humanitarian aid are all provided by Gerald R. Ford class aircraft carriers and carrier strike groups. The class improves warfighting capabilities, contributes to the improvement for our sailors, and lowers the overall cost of ownership. When opposed to the Nimitz-class, every ship in the new class will save more than $4 billion in total ownership expenses during its 50-year expected service life. The Gerald R. Ford class is intended to enhance the carrier air wing speed and power. The ship's systems and layout are tailored to boost Associated Strike Air Force Sortie Generation Rate (SGR), culminating in a 33% growth in SGR over the Nimitz class. During the ship's 50-year service life, the ship's architecture and electricity-produced plant are designed to accommodate future technologies, including direct energy weapons. This nuclear-powered aircraft carrier is a key asset for maintaining maritime dominance across the world's oceans, thanks to its deployed carrier air wing. The value of being able to bring definitive air force to bear from the sea has been demonstrated time and time anew. Together with the ships in an associated carrier strike group, this aircraft carrier is strong enough to carry out tasks designed for large combat missions to deter emergency assistance. History of supercarrier USS Gerald R. Ford. The US Navy inked a $5.1 billion deal with Northrop Grumman Shipbuilding in Newport News, Virginia, to develop and formulate the ship on September 10, 2008. In 2005, Northrop began pre-construction on the carrier under a $2.7 billion deal. The carrier was built in Newport News, Virginia at the Huntington Ingalls, previously Northrop Grumman, Newport News shipbuilding facility that employed 19,000 people. The carrier was said to be architecturally midway operational in August 2011. Development was estimated to be 75% completed in April 2012. Susan Ford Bales, Ford's daughter, laid the foundation of the new battleship on November 14, 2009 in Dry Dock 12. Upon the installation of the ship's upper bow portion on April 9, 2013, the carrier's flight deck was finished, increasing the ship's architectural completeness to 96%. The final of 162 superlifts was installed on May 7, 2013, raising the ship's architectural completeness to 100%. Hull coating, shafting, electrical system finishing, mooring equipment, radar array installation, as well as dry dock flooding were all tasks that required to be completed. The ship was supposed to be launched in July 2013 and delivered in 2015. Associated with manufacturing difficulties, the debut was postponed until October 11, 2013, and the branding ceremonial was postponed until November 9, 2013, with shipping in February of 2016. Highlighted points of supercarrier USS Gerald R. Ford. The Gerald R. Ford is the flagship in a new series of aircraft carriers that will outperform the old Nimitz-class. The Gerald R. Ford has AN/SPY-3 and AN/SPY-4 passive electronically phased array multifunction radar and an island that is 140 feet further aft and 3 feet nearer to the ship's edge as compared to the Nimitz generation. The Electromagnetic Aircraft Launch System, EMALS, would release all carrier aircraft substituting conventional steam catapults. This breakthrough eliminated the need to create and retain steam, clearing up valuable space beneath the deck. Gerald R. Ford could indeed deploy 25% more planes per day with the EMALS as compared to the Nimitz-class, and he can do it with 25% fewer members of the crew. Over a 50-year lifespan, the Navy predicts that it will save $4 billion in operational costs. These performance upgrades were troublesome in Pentagon testings. Thus, final software remedies for several of the issues have had to wait till the ship's post-shakedown accessibility in 2019. General characteristics of supercarrier USS Gerald R. Ford. Below mentioned are some of the general characteristics of the supercarrier USS Gerald R. Ford to better help you understand its importance and features. The class and type of this aircraft carrier ship is Gerald R. Ford class aircraft carrier. Its displacement is about 100,000 long tons when full load. The length of this aircraft carrier ship is approximately between 333 meters or 1,092 feet to 337 meters or 1,106 feet. The beam lengths of this supercarrier are as follows. For the waterline, it is 41 meters or 134 feet, and for the flight deck, it is 78 meters or 256 feet. The height of this aircraft carrier is approximately 76 meters or 250 feet. It has a total of 25 decks. There are 2 A-1B nuclear reactors in it for installed power. It also contains 4 shafts for propulsions. This high-agility aircraft carrier ship has a speed of 36 knots, which equals 56 kilometers per hour or 35 miles per hour. The range of this ship is said to be unlimited but numerically around 20 to 25 years. It has a total of 4,539 complements, including the air wing. The AN/SPY-3 multifunction radar, or MFR, X-band active electronically scanned array is the ship's sensors and processing system. It also includes an AN/SPY-4 volume search radar, or VSR, active electronically scanned array in the S-band. Its armaments are explained in detail further. For surface-to-air missiles, it is equipped with 2 of the RIM-162 ESSM launchers, 2 of the RIM-116 RAM. Meanwhile, for guns, it is equipped with 3 of the Phalanx CIWS and 4 of the M2.50 cal machine guns of 12.7mm. It has the ability and space to carry 75 plus aircrafts, unlike any other aircraft carrier ship. The flight deck of this ship has the following dimensions: 1,062 feet into 256 feet, or 333 meters into 78 meters. Supercarrier USS Gerald R. Ford facts. The Ford class includes technological improvements that make the carrier more competent and productive while also allowing it to incorporate future technological breakthroughs with reasonable simplicity. CVN-78 and future Ford-class carrier package steadily increasing warfighting functionality and augmented defensive capabilities in a plowable bundle with elevated functionality and diminished total ownership costs through, for example, manpower reductions as well as innovations such as greater electrical production from the nuclear power plant, the consumption of fiber-optic networks, advanced corrosion authority, and the use of innovative composite materials. The island on CVN-78 is shorter as well as further forward than on prior carriers, allowing the ship and air wing to deploy more aircraft's flights per day by providing a greater area for aircraft operation and aviation maintenance. Legacy steam-powered components have been overhauled with electric drive components aboard CVN-78, with 3 times the capability of any preceding carrier in terms of electrical production. The ship is ripe for future upgrading with new and developing innovations during its 50-year service life. Over the life of the ship, a longer period between servicing accessibility provides for more steaming days. The Advanced Arresting Gear System, a follow-on to the Nimitz-class Mark VII system, allows Ford-class ships to retrieve both existing and future carrier-based tail-hook-equipped aircraft. AAG enables the recovery of a wider variety of aircraft and decreases the fatigue impact load on recovered platforms because of its increased control. Built-in test and diagnostic technologies are included in the AAG design. The advanced weapons elevators, which enable the quick transfer of munitions from magazines to aircraft, provide improved weapons and materials handling. Ford-class airplane carriers use cutting-edge technology for launching and recovering landing aircraft. Modifications in hull structure, firefighting equipment, and weapons emplacement are all part of its improved survivability. The F-35C Lightning II, FA-18EF Super Hornet, E-2D Advanced Hawkeye, EA-18G Growler electronic attack aircraft, MH-60R and S helicopters, and unmanned air vehicles are among the Navy's most advanced aircrafts which this aircraft ship is capable of carrying.